another session of whiteboard videos. Today we'll talk about how you can balance explainability and complexity of your machine learning solution. As a data leader, how do you guide your teams to make that critical decision? This can have a huge impact on your user adoption and business ROI. Years back, we were working with a telecom client in helping them control their customer churn. The business head explained to us how they're using a heuristics-based approach to roll out promotions to the customers they thought might churn. With a scientific algorithm, a machine learning algorithm, we used a simple model to come up with a set of factors. When was the last call made, the value of the last recharge, the number of recharges, and with these factors, the model is able to tell that the customer was likely to churn or not. This delivered a 39% improvement. As we were thinking about it, the client got pretty excited. They said, "This is exactly what we want, let's deploy it." So we said, no, we can do even better than this. So we went back and came up with more complex black box models that delivered a 66% improvement. We were pretty excited, but then the client got thinking. The business head, while he was convinced, he couldn't convince the marketing teams to use it. Here there was a user who had made a call 5 days ago, but the algorithm was saying that this person would churn next month. So it was not intuitive and it was not acceptable to the users. So no amount of coaching helped. So this was a failure. Lost investments and lost effort. How can you avoid this? What are the 4 steps that you should follow? Step 1, understand what's the room for error. Understand the business problem, talk to the users and find out how much of a wiggle room do you have. If you ask the users for a metric, they would always ask for 100% accuracy. But try to understand, what are you really trying to achieve? Are you trying to land on Mars or are you trying to identify cats? That will give you a sense of what is the room for error. Step 2, understand the user's data literacy. How trainable are they? Are they really early on in the stage, in which case you have to be really gentle with them and provide more support. Whereas if they can handle complexity, you can talk AI and more advanced techniques. Step 3, build an algorithm leaderboard. Look at the potential set of techniques and start building them and looking at the accuracy. So with this, you will get the range of possibilities. Then step 4 is to evaluate with all of these data points. So you have users' data literacy on the x-axis and room for error on the y-axis, and we've created this 2 by 2. So when the user's data literacy is low and the room for error is high, which means this kind of a scenario, so it's better to go for a simple model and watch out for going for a complex algorithm like what happened here. So whereas if the user's data literacy is high and the room for error is low, maybe a Mars landing kind of a scenario, you can afford to go for a complex solution. You don't have to, but just remember that you have the ability to scale up complexity, while by all means look for a simple solution. What about these 2 quadrants where the user's data literacy is low and the room for error is low as well, and vice versa? Here's where your model accuracies and 3 other factors come into consideration. What is the engineering complexity that your team can handle? What are the infrastructure costs? And what is the maintenance to run it, host it, and what is the total cost of ownership in the longer run? These are important factors that will help you balance both and decide. So as Einstein said, everything should be made as simple as possible, but not simpler. So it's really a fine balancing act. Do share your thoughts, what you think about this approach, and hope you had fun watching this. Thank you.